Well, I must have had a moment of free time. I decided I was going to help my buddy with his airboat fix a couple leaks and such. Well, today's video is about motor mounts and what we're going to do to make those a little bit better. Yeah, we didn't get off track at all. And it's also about what I don't know about airboats and what I'm trying to learn about airboats. And hopefully these motor mounts work. It's a car engine that connects to a prop that gets put into a boat. And everything else I know about airboats, you couldn't measure with this cup. But I'm about to learn because I'm working on my buddy's airboat. And we're going to redo the engine mounts because these 1/2 inch bolts go through a hole in a steel plate that is a 1/2 inch. So there is no vibration isolation in any of the mounts that are on here. Having said that, I've done a lot of looking around at airboat motor mounts, and I'm trying to learn, and I found out that airboat motor mounts are like this, for the most part. They use a rubber cone in them, and the rubber cone is not strong enough. Even the harder rubber cones, from what I'm reading and what I'm seeing on forums, is not strong enough to hold up the weight of a motor that was stolen out of a truck, car, whatever. 350 Chevy motors are a lot heavier than aircraft motors, so these won't hold the weight. So the solution to all that seems to be to put these in place of the rubber isolation mounts. There's no isolation of vibration with one of these babies. That thing's as hard as a piece of aluminum almost. So unless your bolt wiggles in the hole or this wiggles in the cone, there's no vibration isolation with this mount. What I'm going to try to do is use rubber mounts and additional support, rubber support underneath of this at the front and on top of this at the rear of the motor to make it actually isolate a little vibration. That's all it's supposed to do, is isolate a tiny bit of vibration. But when you mount it solid, it can't isolate anything. So, in the spirit of overkill, which is what I like to do, let's build some motor mounts. So here we are at the side of the motor. This is the original motor mount that was in here. This looks like a good idea. I mean, it's got a rubber pad there, right? Until you take into account that this 1/2 inch bolt is tightened all the way through here and tightened down flat, steel to steel, top and bottom. Once you tighten that down flat, steel to steel, that takes some of the isolation ability of the rubber out of it. The next thing you have to take into account is that these holes, I don't know if you'll be able to see this on the camera, are so tight that you can actually see the threads in them. See, that bolt won't just push through that hole. I have to turn it to get it through that hole. Very little vibration isolation there. So, in the spirit of not reinventing the wheel, I've just cut those motor mounts apart and I'm going to use the original inner plates. They're not perfect, but they're close enough to perfect. The plan is weld this approximately right in this area so I can still get to that bolt in the back to tighten it. Bring an ear up here so the bolt can go through the rubber cone and the motor mount bushing. And then make a cradle underneath of this that will wrap this rubber around this a little bit and hold some of the weight so that the little area of bushing right here isn't holding all of the motor weight. This will have to have something underneath of it that pushes up on it that has some adjustment to it because I won't be able to get this perfectly aligned. So let's see how this all works out. This may give you a bit of an idea of what I hope to end up with. That's your upper half. This will be the lower half of it. This long sleeve around the bolt sticking out the front, I kind of stole that from some stuff I saw online for airboat motor mounts. This will then have a cradle with rubber between the bottom of this and the top of the cradle to help support some of the weight, so this is not holding all the weight. mounted in with 2 bolts through to the bottom. And that should do it. For the rear of the motor, I'm going to mount the motor mounts basically the same way I see them on the internet mounted, on the videos and all that, except for one difference. I'm going to put a washer around the top of it for an additional support area, and then I'm going to cut a hole in a piece of rubber so that it will sit down alongside of that cone and help support some of the weight of this big chunk of cast iron. I'll take a moment right now to address both of the comments that are going to come in about how if your prop is balanced, you don't need vibration isolation. This is a motor out of a car or a truck. Same as in many pickups and stuff like that, V8 engine, it has vibration to it. If you don't believe that this motor needs vibration isolation to separate it from this, I mean, sure, this is just for sport use, but the vibration is not good for any of the components on this. Just take the motor mounts out of your truck and replace them with these and get back to me. And now, before we cut the motor mounts off, let's measure this motor and see where it's at so we can put it back in the same place. What the? Continuing on in learning about airboats, I hung a plumb bob down the center line of the crankshaft in the rear and down the center line of the crankshaft in the front. And I laid a steel ruler evened out across the bottom and found out that the motor is offset to the left about 1/4 to 3/8 of an inch. I found something else kind of strange when I did the measurements. The front of the crankshaft is left about 1/2 inch further than the rear of the crankshaft. And I wondered if there was a reason for that. And I started doing research, and I found out with aircraft, there's a thing called P factor, which is the relative angle of attack of the propeller, the downward blade versus the upward blade, when the airflow is not perpendicular to the center line of the prop. In other words, if the plane is slightly nose up, the prop will have a bigger bite on one side than the other. That's on the downward side. So the downward side on this is this side. So that side will have more of a bite on the air because the boat travels through the water slightly nose up. So whoever built this boat either got lucky or they knew what they were doing when they put that angle to the left on the motor, because that, according to the videos I've watched, would be the correct angle for the rotation of this prop for P factor. And it is about the correct amount of angle. So I'm going to say they knew what they were doing, because the owner of the boat has told me that it never fought him as far as going in a straight line. It's always been a nice, easy handling straight line boat. So we're going to leave that angle the same. And if you don't understand the P factor thing, I'll put a link in the video description below to a video that I watched on P factor, because I didn't have any idea about it until I measured this motor and said, what the heck, why is it crooked? I would say the guy knew what he was doing, because it's angled the right way, and also the weight is slightly offset to the left to compensate for just cruising torque. Not much to the left, but every little bit helps. So I'm going to put it back exactly the way it is with rubber isolation mounts. And now back to our regularly unscheduled, doing way more than what we really need to do project. Well, before we do anything, the engine has to come out, because there were some clearance issues in the original design. That'll work. That'll work. That'll work. I'd say that one's stuck in that hole pretty solidly. All right, now, yeah. Well, I have to get this out of here, pretty much. All right, she just glued to the rubber pad, that's all. All right. Now, how do I get it over that? Because it's about as high as it's going to go. So I can't go forward because there's a tab hanging over the leg of the engine hoist. I thought it was just going to be a simple matter of rolling the engine stand out from underneath the engine once I did that, but I forgot about that tab. Yep, jumped over it. All right. Now we're in business. Yes, yes, yes. Now we just rotate the motor a little bit. That way. Whoop. One more hop and we're done. Don't get underneath the motor. Motor is off. He wants to clean that up and paint it and stuff, but now I've got room to be able to cut some clearance for the oil pan right here, or move these bars over or something. Not sure what I'm going to do yet. Because she needs a little bit of help in that area. I just need a little bit of clearance for the oil pan, so we're going to do this in the simplest and quickest way possible. Of course we are. That looks pretty good. It may not be perfect, but it's close enough to perfect. Maybe now we can get back to building some motor mounts, because there's always projects in the way of your projects before you can do your project that you originally started on. I don't know how that happens, but something like that. Well, and I can say, cutting out this second motor mount, well, at least marking it out, is going to be much easier than the first one. And now all I have to do is mark out this piece that's going to fold and make that. All right, set up to do a little plasma hacking. All we got to do is hack it out to shape, not set my feet on fire. All right, bending jig. Could I build something better to do this with? Probably. Does this work? Well, it worked once. Let's see what happens this time. It doesn't bend it all the way because this, of course, is going to hit in here, but I'll finish it up. Got to get a good start in the bottom edge of it. All right, there it goes. It's starting. Get my emergency support out here. Not working as good as it did the first time. Ding, ding, ding. It still wants to be a curve. The last one did not do that. Well, folks, this is what happens when you put something on video. And I videoed the second one just because I wanted to make sure I could do it, you know, without throwing a whole lot of video on the cutting room floor, so to speak. So we're going to go to the old barbaric method of making a 90-degree bend. And there's too much bounce in that. Oh, that's just a tiny bit short. Never throw any pieces of scrap wood away. They're always useful for something. That's working. It is a motor mount, and the rubber parts do have some flex in them. So, it does not have to be perfect, but perfect like that will work. And we're pretty close that way. A little bit, little tiny bit more maybe. I like it. I guess the real question is, does it look anything like the other one so far? Well, we line it up on that end, and it lines up down that side, and it appears to be about the same height. I still have to cut the point off this one. And then we bend these two ears in, and they support this shaft to keep it from wobbling up and down. All right, now I have to figure out the exact position of this part on the actual engine mount plate. I have to get it close as I can for height. In and out is the most important part, because there's another bolt down here, of course, and I don't want to interfere with being able to tighten that bolt. And also I need to have this setting at the right point, because I have to saw a hole in this plate for this nut to go down through, and that hole can't hit the top of this upright, so it has to be far enough in to clear that. So let's see how this works out. Pick my stick up off the floor. Precision shim here, man. Precision. See, that's exactly perfectly level. All right, let's bring it down a little bit and see what happens. Woohoo! And that bolt even clears everything. This might actually come close to working someday. All right, other than being against that tie wrap in the back and it leaning it slightly, it seems to be in the right spot right there. Pretty good guess with that little block of wood. When I get ready to weld this thing on right here, that angle is going to be critical, because it's going to, if the angle of this is off, like down in the front, it's going to come down in the front and twist in, and that will make this motor mount do that. So what I'm looking for is as parallel as I can get it. All right, well, you get the idea of what I'm doing. A little bit of finagling and adjusting here, and I'll get this set to the right angle so that it's where I want it at, and I'll be able to weld this to that, and that'll be my next step. All right, if anybody's still watching the insanity of the progression of this build, I'm at a point now where I can show my idea of how this is supposed to work. The whole thing is to get rid of these ridiculously hard plastic bushings that were put in here. Way too hard. And put rubber ones back in it. In order to do rubber ones so that you actually have some vibration isolation, you're going to need to support the weight on something besides just this little bit of a top edge right here. That bolt will just squeeze right through that with the weight of a 350 Chevy engine hanging on it. So to do that, I put a plate in here like that, and that plate will have a piece of rubber on top of it to help support the weight. That rubber will still isolate vibration because it's rubber. Once this upper motor mount is put on here, there's no way that I can compensate or calculate the thickness of the rubber and the density of the rubber to get this to support kind of equally with this. So the lower support for the lower rubber part is adjustable. And once you get that set up, then it should keep it from sawing its way through this little piece of rubber on the top. So I'd be able to put rubber bushings in here, help support the weight with this rubber bushing, and actually have some vibration isolation. We hope. I will post updates in the video description as time goes on to let you know how well these things are doing and whether they succeeded or failed. Well, this is it. The motor mounts ready to go together for the first time with rubber mounts in them. Should work out pretty good. Put the additional rubber weight support there. Put the additional rubber weight support in here. And let's slide it in place and see what happens. Just make sure it's all the way up here. All right. Let me get where I need to be on this. All right, bring it on back. That should be good enough as far enough back for right now. We should be pretty close right there, just a hair more. Oh. Give me just a little bit of up. So it was looking pretty good at first. Yeah, it's a little extra angled up in the rear. You can try dropping it a bit. That should be about 1 degree because the motor mounts are built at exactly 1 degree. But if it's against that, it might be a little snug. Whoa, right there. Should be just, yep, that's 0.85 right there. Some more parts. So the angle right now is 0.80, and the front motor mounts were built at a 1 degree angle, or they're set up for a 1 degree angle because between 0 and 2 degrees should be the sweet spot. So now all I gotta do is drop these in the back. Can't hit that. Dee 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 dee. Get it through just far enough to get a washer on it. And I'm doing all this just so I can prove that it works. Push forward on the motor a little bit. All right, there, it just went enough just by hand, just with me pulling on it. All right, go around to the other side, do the same thing. And that's the motor setting on the new motor mounts. The plan is going to be this bolt right here will raise this cup up. A brief explanation of Project Overkill. In most airboat applications, these motor mounts are used with just the bushings that are right here on this main shaft without the cradle. That leaves the entire motor supported by this much area of 2 rubber bushings. The weight of the motor just eventually sags through and a little bit of vibration eats through the top of the bushing. With this, you can adjust you can adjust the center bolt up. And you can see that raising up. And you can also see it pushing up against the bushing. That puts the weight on a larger area of rubber, keeps it from eating its way through the bushing. It should last virtually forever, just like a motor mount in a car does, because it has enough area to support the weight. And once you have this tightened all the way up into place, so it's supporting a good percentage of the weight, you just tighten this jam nut right here up. And presto. This bolt is a little longer than it needs to be. I'll change that out later. That video got to be a lot longer than what I thought it was going to be. I apologize for that. But if you made it all the way through the end, you're either really interested in what's going on in the shop, or you're about to build a set of motor mounts for your airboat, and you've probably already decided you're not wasting this much time on it. Anyway, have a great day. Thanks for watching.